All right, everyone, welcome back. For today's lecture, we're going to be primarily focused on what's looking like a three-part Arkanoid project. So we'll do a real quick review of the content from last lecture, and then we'll dig into the actual content of Arkanoid. So as part of your week 2 project, we discussed going through and adding the back one's functionality, meaning all we had to do was store the current location in a previous, and then once we pressed a particular button, X in this case, it would restore that as the next going forward location. So it's just recovering, it's storing and restoring state. We also looked at the different bits and pieces of getting our text not just to the debug console, but also onto screen. So it meant we never had to leave the game itself to try to figure out what was actually being presented. We looked at a number of ways to customize that whole system just in general. There's a lot of different features, settings, gives you all kinds of different abilities. We also looked at how to find those objects or find those either game objects or text objects in our scene. We also kind of glanced at and glossed over the concepts of accessing some of these methods off of the game object class, the object class, which is where that find object of type comes from. We just omit it because it doesn't need to be there. Visual Studio told us like this darker shaded out object doesn't need to exist, so we can omit it. It's actually part of the hierarchy. If you go looking up through the the mono behavior that our script derives from, you can right-click on that and say go to definition and see what's inside that. See what its parent is. See what its parent is, and so on all the way up. And so you can start identifying where some of these methods come from. And then we looked at the lowercase g game object, meaning this particular game object that this script is currently attached to. We also looked at how we could liven up our display to the user a little bit by adding various tags to the text. And the debug console as well as the text on screen would show that liveliness. We also took a look at a couple of different methods for submitting your project, be it the whole thing, zipping up specific folders, or doing an export of the project. So that concludes the review of last lecture. So today, I'm going to start a 3-part kind of construction of an Arkanoid project. Now, for those returning or looking at the videos that we've already got currently posted, you will notice that the code here differs slightly from the code from last month. I experimented with a few more different techniques, a few more other features, and that kind of stuff. So it's going to basically have all the same bits and pieces, but how we approach it, how we get this stuff on screen initially, and how we interconnect with different things is going to follow a slightly different pattern. So for today's lecture, we're going to construct the initial Unity project itself. Now, this is kind of a 2-part piece. There's a number of things we have to construct over in the visual editor, right? And then there's a number of things we have to construct over in code to actually link this stuff up to give it real functionality. So we're going to go through and take a look at the project setup overall, what kind of settings and whatnot we need to put into place to mimic the original Arkanoid project that we're going to basically clone. We're going to take a look at the scene content, referring to like camera settings and different objects for like our play area and so on. We'll take a look at the initial skeleton. I mean, it doesn't have really anything in it at this point, but in next lecture we'll start to flesh out a number of the interconnected tissue between all these different objects. But for now, the game manager is actually going to directly apply to some resolution settings that we're setting up as part of project setup. We'll take a look at the paddle, actually getting a thing on screen, the paddle on screen, as well as the code to drive it, so that we can, have something moving around our screen. Then we'll construct a ball that can be attached to the paddle, so it follows along with it. And then on one of our key presses, we launch this ball out into the scene. We'll also, because we're faking physics, right? We're using Unity's physics engine for a number of things, but we're also faking it in different respects. We're not using gravity where we're doing certain checks like all the time as opposed to periodically. So I'll go through some of those settings so that you can see both how you could set it up in code and how you could set it up in the visual interface on the object itself that we're going to fool around with the components that make these things up. Then we need some kind of a target to actually bounce the ball off of to eventually give us scoring information. So then we'll construct a brick object and flesh that out. We'll also address some of the general concerns when it comes to how some of this stuff can count up. Like, you can apply scripts to things, and Unity doesn't care what the object is. If the script is there and that object comes alive, that script gets executed. So we'll be taking a look at how you can kind of safeguard with those kinds of scenarios. Basically, your functionality will still work, but maybe it'll introduce different kinds of bugs. So the idea will be to give ourselves as designers, as programmers, a heads up, or to other developers who may come along later working in our project and may create something not realizing that they need to do steps A, B, and C, and then they expect it to work. They introduce various bugs. So we'll give ourselves kind of warnings, like heads up inside the console, not just our debug logs, but we'll go one tier higher and give ourselves some actual warnings so we can go back and say, oh, right, I needed to do X, Y, or Z to get this thing properly functioning. The next two lectures are going to primarily focus on stitching all those right now it's going to be the four pieces: the game manager, the paddle, the ball, and the brick. Next lecture is going to take a number of the things that we write in the ball, brick, and paddle, and we're going to refactor some of the code so that it takes advantage of the game manager. The game manager itself is going to represent our central controller for the entire game. So just as an initial, let's get the thing up and running, we'll hard code a couple of values, but once we actually get into how the game manager is going to control flow and function, then we'll modify that. So instead of being local variables to that script, we'll actually talk to another location. Additionally, as we continue forward, we'll take a look at level management, being able to jump between level 1, level 2, start, end, that kind of stuff. We'll also take a look at every time we hit the brick with our ball, we might get points for every impact. And then we might get more points for actually destroying the ball. So we can track that information. And we can display that in different ways. We can kind of keep track of some of that stuff. Then we'll, towards the end, take a look at the submission, just in general, what you need to do to actually get this thing submitted. We'll also kind of glance over the rubric to make sure that we've hit all the topics and whatnot. Okay? So at this point, that concludes the slides, and now we can start digging into actual code and into Unity. So what I'm going to do is open up Unity. And actually, before I even start constructing a project over here in Unity, I want to take a step back and look at this thing from a design perspective, right? What exactly am I building? What are the different kinds of things that I want in my head as I construct this thing? So I'm going to pull up the Arkanoid entry over on Wikipedia. So this is the basic project that we're going to try to replicate, not all the power-ups and different abilities here and there, but basically this UI that we have here, this paddle, the ball, the bricks, the general area here. And as we continue forward, we'll have a score. It won't necessarily be a high score, but it could. So let's see here. So this is what I'm going to try to build. Now, one of the things I want to try to retain, and if you look at last month's videos compared to this one, you're going to notice I'm specifically going in and making some resolution updates. So this part of the project will definitely be different. Notice over here under the just general information, under display, I have a specific resolution for this particular project. Now, it was an older thing. We dealt with older hardware and so on. So it's 224 pixels by 256. So I want to retain that kind of play space. I don't want it to necessarily be 16 by 9, you know, a widescreen kind of play area. I mean, that could work. It's worked in the past. But for this particular version, I want to be more true to the original vision of this project. So what I'm going to do for my design is try to recreate this exact same play space, the dimensions, width, height, that kind of stuff. But I want to take these numbers because on most of our modern machines, these are really tiny. They're about the size of a stamp. So I want to actually scale that up. And I've already done some of this math ahead of time just to see what looks good, both on screen and what works correctly in code. So when I start punching in these values, I'll mention the calculations and whatnot. So if you wanted to try to figure it out for yourself, but also why I went with certain sizes. So in this case, I chose 4 as a pretty solid scale up of this original design. So what I want to do is just real quick save this image. I'm going to dump it into my just my downloads, arkanoid.ping. And my intent here is to just use this as a blueprint, right? I'm going to use this as my construction yard. Notice this is also one of those things where when you're starting to deal with external resources, you have to worry about like attribution rights and that kind of stuff. If I was using this in the project, then I'd want to say like, this is where I got it. Here's the author. That's why this dialogue's popping up with Google or with Wikipedia rather. In this case, I'm only using it as alignment for my stuff, and it won't be turned on in the final version. In fact, in the final version, it should be deleted. This is all my code, my assets, everything I'm writing from scratch here, not including this asset. Okay, so now that that's saved, over here in Unity, I want to create myself a new project, and I'm going to name this Arkanoid Prototype. Arkanoid _ prototype, and this is going to be for the 2017-11 term. In this particular case, I want to stick with 3D, right? Unity is a 3D engine. It does support 2D stuff, but for the kinds of calculations and whatnot that I want to do in this particular iteration, I'm going to make it look like it's 2D, but I'm going to use all the 3D functionality. Don't want analytics, and as far as location, I'll just dump it back into this location with all these other things. Okay, so create project. Now, some of the things that I'm going to go over here, they're not necessarily things that you need to really concern yourself about, but if you decided to, like, number one, we're going to see this thing in the editor, so we need to make sure that our layout is proper. But if you decided to actually build this game, right, you did Command-Shift-B on the keyboard, brought up the play area, actually brought up the build dialog and constructed this thing, then that final version, there are different settings, right, as far as aspect ratios, screen resolution, that kind of stuff, that also need to be possibly adjusted. You don't necessarily want to construct it inside your game view looking one way, play it and have the resolution all wacky or be able to rescale or deal with those kind of issues. So I've gone ahead beforehand and written a quick little script that's actually going to introduce the concept of our game manager. The game manager itself is not going to really come into its own in terms of stitching all this stuff together until our next lecture. But it gives us a placeholder for some of this functionality. Now, remember I said a couple of times that when you have a script out there, if it's applied to a game object and that game object comes alive, that script will be run. So it can be an arbitrary script at any point doing anything, and as long as it exists in your scene, it's going to function. So I'll take advantage of that little feature and then later on refactor it. Okay, so the first thing I want to do is set up a little organization for myself. Right? I know I've got a handful of things that I'm going to be creating, and so I need to just organize the project going forward. This is a best case kind of scenario because you don't want to have assets kind of scattered all around. You want to try to retain some form of organization. So I'm going to create a folder. I right-click, said create new folder, and this one I'm going to call scenes, just like we've done before. Now I want to Command D to duplicate that, F2 to rename it. I want to call this one scripts. I want to duplicate this one more time. I'm going to give my objects later on some visual materials, which will try to mimic the stuff that we see over there in that Arkanoid image that we pulled in a second ago. So I want to make a materials folder. Okay. I want one more folder, and this will come into play in next lecture where we take our objects and we start dealing with multiple scenes, multiple bricks, and that kind of stuff, because you've learned in a past class where we deal with prefabs, right? So I want to be able to go through and tune some of these things and have some settings propagate through all of my objects. So I want a prefabs folder. Okay, and now the final folder that I want is strictly for getting that image that I created a second ago up on screen. I don't technically need to do this, but I want to stay orderly, so I'm going to duplicate that folder one more time, and I'm going to rename this to sprites. Okay, so I want to pull that image over real quick, so I'm going to right-click on the sprites folder, show in Explorer, and I want to open up my downloads directory and just grab that image that I had a second ago. So over here, let's see here, in sprites, just move the Arkanoid ping into that folder. Okay. Now Unity is going to see this file. It's going to do some import, like understanding of the asset itself. Well, this is fine, except you'll notice I can't drag it into my scene. If I click and drag, I get this no functionality is available kind of indicator. So what I need to do is I want to see this image as a 2D sprite. That's how it interacts with this particular scene. So I'm going to go over here to texture type, hit the drop down, and go down to 2D and UI sprite. That changes some settings. I don't care about any of the current defaults and whatnot. All I want to do is hit apply. Now you'll notice the Arkanoid image now has a disclosure triangle next to it. And underneath it, I have a little, what looks like some of that UI stuff that we created last time. So this conversion will now allow me to click and drag either this named Arkanoid or the Arkanoid right below it, right, and drop that into my scene. And now that I moved it, I'll put it back. There we go. So now I have this object over here in my scene. But notice it's fairly small. I'll get to that here in just a second. This Arkanoid that's in my scene, I actually want to just rename this to be, let's see here, Arkanoid layout. Right, and this is, I will get rid of this image later on. But for the moment, I'm dealing with an empty scene that could potentially crash. So let me go ahead and save that. So Command S, I'm going to go down to my scenes folder. And this one, I'm going to start constructing level _01. So now I have level 1. I'm in level 1 and everything's cool. Okay? So I said earlier that the basic resolution of what we saw on the Wikipedia page, 224 by 256, kind of small. So I want to scale that up. Well, I went ahead and I looked at this image, and if I scale it up 4 times, the play area that I'm going to create, it's slightly bigger than that play area. And that could be something in the graphic itself or whatever. So I went ahead and I said just a tiny bit smaller than the play area. So with the Arkanoid layout selected, I want to change my scale to 3.9 in the X and 3.9 in the Y. Now that gives us a little bit closer to what we're we're actually looking at, right, in terms of play space. Now, you'll notice that the camera is actually up too high. So at this point, I want to do a little bit of customization to I'll come to the camera in just a second, but I want to map the area that I'm actually dealing with right here to this object, right, this image that we just dealt with. So to do that, you'll notice up here in my game view, I've got this drop down. I actually have a number of other windows, but the real estate is a little small here, right? So if I just tear this off, we can see there's a number of different options across here. I'm primarily focused on this aspect settings area. And you'll notice it says standalone 1024 768 or 16 by 9, 10, 3, so on. So I can change how this thing actually looks. So I want to take this tab and put it back so that I have scene view and game view side by side. Now I want to use the standalone size, but I don't want 10 by 7. So if I go up to File, Build Settings, I get this dialog, right? And we'll, as we continue dealing with individual levels, we'll come back and take a look at this scenes in build so that we can actually go places. These files have to be burnt into the actual build that we ship, otherwise we'll get an error saying that scene doesn't exist. But what I want to do is down here at the bottom of this dialog, I have player settings. So if I click on that, over here my inspector changes to be slightly different. Now I have a number of different options available. So I want to make a couple of adjustments here so that this thing actually looks correct based on this area, this play area. So number one, I want to turn off the default as full screen. I want to map this aspect ratio and this resolution to that image but scaled up 4 times. So the math is basically taking that 224 and the 256, multiplying that by 4. So that gives me 896 by 1024. Okay, so we get closer as far as everything that's mapped to this particular view. All right, we're starting to get there. It's looking a little better. Let's see here. This, like I said, if you actually build this thing, you'll get that Unity pop-up to pick your resolution. In this case, I don't want that to override my settings. I want to lock it down, so I want to turn off the display resolution dialog. I want it to be forced to this particular value. Okay, so that concludes all the settings that I needed to modify here to make sure that my final build looks like my running build here in the editor. Oh, yeah. How big the image itself is? The image itself coming from Wikipedia is 224 by 256, and I scaled it up by 3.9. So on the Arkanoid layout game object that has this sprite attached, I just increased its scale X and scale Y by 3.9. Generally speaking, this image is mapped to 4. Yeah, no worries. Yeah, this whole setup process, there are a number of different little options here and there, a number of different things to get properly set up before actually going into the code. So, you know, once we're in code, all the rest of this stuff actually will make sense. So this is the setup that's necessary to get everything visually functioning the way we want it to. Make sure our bounds are correct, that kind of stuff. Okay, this is the proverbial blocking out of your level before you actually start really putting the functionality into it. Okay, so at this point, you'll notice that the standalone numbers changed as well. So it's mapping to what I just said over there in the player settings. Okay, and I'm going to save my scene, so Control S, just to make sure everything's cool on that side of things. Now, I also mentioned that there was the possibility that when we build this thing, that you might have the ability to resize the window. Depending on your OS, it might remember those resizing options. So I want to force a specific resolution. I want to force this exact same setting, but over there in the app whenever it boots up. So to do that, this will introduce the initial skeleton of our game manager. This thing will grow as we continue on with the project and start to stitch all these other bits and pieces together. But for the moment, it's a quick little introduction to here's how we can just reinforce one particular rule. In this case, it's the resolution. So here inside my level, I'm going to right click and go to create empty. Okay, and making sure that that's at 0. This particular object won't really play in the world, but it's always good practice to make sure your new objects are at origin. I want to create a script, and if I just start typing game object, it automatically understands that I probably want a script. Sorry, not game object, game manager. Okay. And now this game object that I created up in my hierarchy, I want to rename it to be manager. All right, that way we keep a consistent naming across the board. So our game manager object inside our scene and the game manager script that we have inside our script right here inside our project view, I want to move it up to my scripts directory, again, keeping everything organized. And when we move scripts around, it triggers a recompile, so give that a second to deal with what's going on. Okay, and real quick, just to jump into code to make sure that this is proper, we won't for this particular lecture, we won't be revisiting this script, so we can get it out of the way fairly quickly. So double-clicking on Game Manager. I just need to make one adjustment and add 2 lines of code. The first adjustment, instead of using start and update, if you refer back to that slide in that link in the very first slide of the very first lecture, I showed you Unity's execution order, how it flows in any given frame and during startup and shutdown, which methods get called first. Now we're going to take advantage of some of those features of the engine, knowing that certain aspects of the physics engine get updated before collision actually gets processed, will give us the ability to go in and kind of capture information that will be destroyed once we actually start dealing with the collision information. So we can, like we did with the preserving the back state in our last project, we can hold on to that information because it's going to be lost, and then we can start manipulating it going forward once we detect, a collision or whatever. So various methods, start, update, they're listed inside that document. Start is one of them, but I want to go ahead of start. I want, as soon as Unity fires up its scene, before any of my game objects become, populated into the scene, I want to do an initial wake up. This is earlier than most of the previous calls. This one is called awake. Okay? And now I said I want to give my resolution I want to map it to that image. And I took that image and I scaled it by 4 times. So what I want to do is apply a scale of 4 to the initial width and height from the image, but then apply that directly to my screen. So I'm going to say screen dot set resolution. I'm going to say 224 was the original image size multiplied by in scale, and that's the width, and 256 times in scale, that's my height, and I don't want full screen for this particular object, and I'm going to allow any of the extra settings to just be their own defaults. Okay, so that's it. And actually, I don't need update. I can leave it, but having extra code in here kind of clutters things up. So I'm just going to get rid of those extra couple of lines. All right. So now it's pretty clean. I can get rid of these other 2 if I wanted to, but meh, whatever. Okay. With that file saved, that's pretty much the end of it. For this lecture, like I said, I won't revisit this particular one. So I'm going to go ahead. Anybody need any extra time to? Cool. Yep. Yeah. Yep. So the idea here, just behind the scenes, as you're getting back up and functional, this so Alex in chat brings up a really good point. The script itself, if you're paying real close attention, you'll notice that the icon is not a script like all of our other scripts that we've created. It's actually like a cog, a gear, which initially is like, whoa, wait a minute, am I creating something special? Am I overriding something in the engine? Well, based on all the reading that I've done, all the research into Unity and the forums and that kind of stuff, it looks like somewhere in the engine they probably have some file named Game Manager. It's probably some special system like what's it called? A serialized object or something. You're not there yet, but it's a way of storing data elsewhere. So far, all of my tests show that this is not an issue. Everything still functions correctly. But because the engine sometimes only sees one particular class floating around out there, it'll try to say, oh, you're actually this type versus this other type.
One thing, that there's already a game manager.
Do what?
Saying there, please fix the file error before creating the script. There is already namespace. Sorry. The namespace global already contains a definition for game manager.
Do you? Okay, so your script only has this one, game manager, right? You have the one script.
I know what this is. This happened before.
Okay.
I have it somewhere else, so I did something wrong.
If you look over here inside your project view, just scan down through that list, you should have only one single script object named Game Manager. If the file's duplicated somewhere, this is a very easy thing to accidentally do, especially if you're cloning a bunch of stuff. That's more than likely where it exists. Okay. So that's really the only reason, Alex, why we have that. I'll get to that next question shortly. Let's see here. Okay, so that concludes the Game Manager object and the Game Manager script. The intent here, if you build this game, no matter what you scale it to, this will reinforce the actual aspect ratio, and you'll actually see it scale back to our dimensions. So in this particular game, I don't want people seeing what's outside of the bounds of the play area, so it reinforces some rules. Okay. And that was pretty much optional. It just goes to show you a few other things you can do with Unity, with the other game objects, and so on. Okay. Got it?
Yeah, I had in the first scene.
Excellent. And you say the first scene. I started constructing this thing in a brand new project, so there shouldn't necessarily be any other things out there, because we can actually cause overlap with cross project contamination. Okay.
Quick question.
Yeah.
Why did you set the last part of the resolution to false?
If we take a look at the script itself, you'll notice if I mouse over it, down at the far right, it says the incoming, the parameters that it's expecting, width, height, full screen, and it has one overload. There's another flavor of this. Remember when we wrote constructors for like the candy class or the page class, and I said we have the initial constructor that doesn't have any parameters whatsoever. There's nothing there. Then we relied on properties to set it. Then I said, now I want to take in two strings, the heading and the body or whatever. Giving those additional parameters allows me to customize how this thing is set up. Now, this tooltip is telling me there are two of these things floating around out there. One, that looks a little different than this, and then this one. So if you follow those 3 items in that tooltip, in this particular case, I don't want it in full screen, so that's why I pass in false. So that's, if you mouse over, it's this 3rd parameter right here. And this, by the way, if you Google Unity space set resolution, it'll take you to the documentation where you can see the other flavors of this and what each one of those parameters means. The other version of this takes in an override to the refresh rate. Like if you wanted to enforce 60 hertz versus 120 hertz, that kind of thing, you could apply a number at the end. The system uses a default. It actually assigns it right there in line. Right? If I do comma, you see I now get the other version of my number here going from 1 to 2. Right? The only difference, I mean, these 2 functions are identical, but they're overloaded. I have overloaded? Yeah, overloaded. To give additional functionality. And so here at the end, preferred refresh rate would be this option. So I could punch in an integer, 60 here, and it would, whatever the engine is set to, it would try to override that. In this particular case, I don't care about the refresh rate at all. I want to let it do its thing, but I do not want full screen functionality. So that's why I allowed just that 3 parameter version. Now you'll see something very similar to this as we start getting into the vector 3s. You'll notice that because of the way my math is working for this, it's a 3D project, but it's in 2D, right? It's pretending like it's in 2D. You'll notice on a couple of the vector 3 things that I create, I only assign the very first 2, x and y. I leave z alone. If you look at the documentation for it, it tells you there are other versions of the vector 3 constructor where z is defaulted to 0. And so I don't need to type out that extra. I mean, it shaves just the tiniest bit of time off what I'm writing, but if I don't need to write it, then I can spend that time on other things in my code. So they knew that we would probably just be dealing with this kind of stuff, just x and y, locking in the z plane and that kind of stuff. So this provides us just another shorthand for what we're working with. Let's see here. Cool. Answer your question?
Yes.
Awesome. So now, jumping back to Unity, let's see here, no compile on that. All right, cool. So now we can actually fix what's wrong with this camera. Notice the area around the image. Notice it's, if I select the camera and kind of pull back a little bit, not that far back. So when my mouse jumped to this other screen, I lost where I was. A quick way of getting back with my object over here selected in the hierarchy, I can put my mouse over top of the scene view and hit F on my keyboard, and it'll frame selected. This is also under Edit, Frame Selected. Right? It'll take me back to the object that I'm, wherever it currently lives. So notice I'm dealing with this view frustum. It's a giant pyramid with the top chopped off. So in this case, because it's a 2D kind of game, I don't want to deal with this 3D projection. I want to shift it from perspective to orthographic. So over here with my camera selected, I want to make a couple of adjustments to make this much more like a 2D game. So the first thing, I need to reposition it. Number one, I don't want this Y offset, so drop Y back down to 0. The Z offset, I can pretty much leave that where it's at, no biggie. With that, it pulls the camera back so I can see content. If I put these all on the same plane, I might get flickering. I might get the object that I want to see behind it. So I'm just going to leave that one alone. It's a 2D thing, so I don't need to deal with the skybox. So I want to switch clear flags from skybox down to solid color. And now if I click this, you'll notice the coloring, right? This light blue versus the play area. Now, if I click on the image well, I can manually start trying to pick a color, right? But I can also click on this eyedropper and hunt down a specific color. Now, what I did earlier was I found a nice blue as part of this background, and I chose it. The number that I eventually ended up going with was 0, 0, 173, 0. Okay, that gives us a nice blue to kind of match. And the intent here is that if I turn off the Arkanoid level, it would look, once we populate it, it would look pretty much the same. So back to the camera. The projection, I need to change that from perspective to orthographic. And now notice my image has basically snapped to the bounds of the play area. So now it's starting to actually look like something quasi-functional. Okay? So now as I start constructing, I want to save this scene. Now as I start constructing the scene content, right, the very first thing I want to do is set up some bounds so that when I do create a ball, when I do create my paddle, they don't go flying off into oblivion. I want these things to kind of bounce off of walls. So I need to actually construct that. So here inside my hierarchy, I want to right click and go to create empty. And this time, I don't want it to be offset to the camera. I want it to be pushed back into the scene on the same XYZ as my Arkanoid layout. Okay? Now, underneath this object, I'm going to construct my ceiling, floor, left wall, right wall, and I'm going to move them outside of my visual play area, and I'm going to scale them so that they overlap in the corners. This gives me a region along the XY plane that I can actually start to interact with. So underneath this game object, or in this case with it selected, I can right click and say create a 3D object cube. Okay, and I said I needed 4 of these things, so I'm just going to go ahead and duplicate this 3 more times. And they're in the center right now. That doesn't really matter. I'll move them in a second. So I want to first rename this first one to be ceiling. The next one I want to rename to left wall. The next one I want to rename to right wall. And the bottom one I'll want to rename to floor. Okay? Now, I want to put these in their 4 locations, but then I also want to scale them so that they overlap and cover everything. So the ceiling, I went ahead and I figured that from the center going up to the top, right, if I take a look at my dimensions, 896 by 1024, I know it's 512 steps straight up. And I know that if I take ceiling and I move it to 5.5, that puts that cube just outside of visual range, but nests it right on top of my play area. If I pull it down a little bit, then we start seeing it in our game view. So in this case, I want it just out of view. Now I know, using math here, that if it's from 0 up by 512, and I have that cube is actually 1 unity unit, so half of it gives me that vertical offset, right? So I know from 0 to 512 is 5. I can shave off that 0.5 over here, right, inside my vertical translation, my y. The math that I can do on this is the height divided by the total number of steps I want to make. In this case, the number I get back is 102.4. That's the total number of steps that I would have to get this whole like 2D screen coordinate to real world 3D object math, right? I can take that number and I can feed that back into 512 divided by that number gives me 5. Add 0.5 to it, and I get that exact location. I can take that same number, 102.4, and I can take half of the width. So here, 896, half of that width is 448. I can divide it by that step value again, and I can get the exact horizontal offset to the left and right of my screen. So taking the left wall, punching in those values, 448 divided by 102.4 plus the half step of the cube gives me, in this case I'm going to the left, so that's negative. So negative 4.875. Okay, and again, to figure this out with the ceiling, I eyeballed it, making sure that it was at the top of my screen, and then I just figured out the math, getting it to its actual location. So now if I, whoops, my bad. This is not in the y. This is actually in the x. So negative 4.875 in the x, and in the y, let's set that back to 0. Okay. So now looking at it over here, I'm right along that left edge. Cool. So far, so good. Now I can replicate that math into the right wall and the floor, just by inverting these numbers. But I also want to do some scaling. So the ceiling object, I want it scaled in the width. So it turns out that doing the math on that will give me an x scale of, let's see here, (9.75). Okay, and if I zoom out, that's kind of what I'm looking at. If I take this left wall, I need to scale its y, right? I want to make it vertically taller. So that comes out to be 11. Okay, so now I know the right wall can also be 11, and the floor, just like the ceiling, can be 9.75. Okay. Now to position my right wall, I just need to reverse this 4.875, so I can copy that. Right wall, paste. And the ceiling, 5.5, so that'll be negative 5.5. Okay. So that pretty much puts everything where it needs to be. Now, it's kind of blending with these walls. If it were visible, it would kind of be a little difficult. So when we deal with designing levels, we want some kind of an obnoxious color to indicate to us like a texture has failed to load, a material has broken or something like that. So this will actually introduce us to using materials to just give things in our scene a little bit of color. Now, because I'm dealing with more 2D content, this whole 3D view over here isn't really what I want. I mean, it works. I can switch back and forth to it. But right here at the top under my control bar here for the scene view, I'm going to click 2D. So that'll kind of map it one-to-one. Okay. So down here in my materials folder, you right click, create, and let's see here, material. This one I want to call wall. And I want to give it a color of 0, 255, 0. No, come back. So this obnoxious green color. I can make a magenta, something to really pop to give me an indication that something's there that shouldn't be. So in this case, wall, I want to apply to these 4 walls. That way, if it accidentally creeps into my scene, I can see, hey, this shouldn't be here, fix it. So to apply this one material to all of my objects, I can do what's called multi-select, right? I can select one of the objects, press and hold Shift, select all the way down to the last one, click and drag the wall material, and just drop it onto the inspector. And all 4 walls get that color as well. Okay? So now I want to save that just in case things go awry. Okay? So that gives us our area to work in. Now I actually need to start constructing the objects that make up the game itself. So I'm running out of real estate, so I just want to collapse this. And actually, I can call this, instead of game object, that's not really descriptive, I can call this play area. Okay, and save scene. Okay, and just like with the folders down here in project, We can also organize hierarchy up here by using game objects and nesting objects underneath them. But also be aware that whatever this thing's transform is, it's the parent, so it's going to apply to its children. So if I switch over to the transform manipulator, I can, just with play area, I can start moving around the whole region. And this is where the green really starts to shine. If I start seeing green in my scene, I know that I've screwed something up. The aspect ratio or I've gone out of bounds somehow. So I can undo that and we get back to a clean area, clean scene. Okay, so I'm going to construct 3 objects. I'm going to tune them a little bit over here in my hierarchy, and then as I construct each one of these things, I'm going to create the script for it, which then we'll fill out. I'll create a material for it, so it gives us a little bit of color to each one of these objects before we actually start, really using them in our scene. And then we'll jump over to the scripts themselves. Okay, so right-clicking in the hierarchy, drop down to 3D object cube, and in this case, I want to reset this using the gear, right, to origin. Now, generally speaking, I'm trying to map my content. When I create the paddle, I want to put it about where the paddle's at. When I create the sphere, I want it to be about the size of the sphere, but I'm actually going to control its location by code, within code. So I just kind of need to get it out of the way of my play area so it doesn't start like inside a brick or inside something that it shouldn't be. So I can put it at origin because notice this square, when it was created at origin, it's not near any of the bricks up there at the top. It's not near the paddle down at the bottom. It's not near the death plane down at the very bottom as well. So this is all part of as I construct this project, I'm going to get close with the numbers. It might not be 100% accurate because a lot of this is like eyeballing it. Again, I'm going off of an image that's not 100% pixel accurate. It's a pretty close approximation. So I'm just going to throw in a number of values that I came up with by eyeballing this stuff and making sure everything was correct. Now for yours, you're welcome to do the same thing. You're welcome to get really detailed with this stuff or just kind of throw them out there in your scene. It's totally up to you. When you start creating things, like if you actually look at some of the levels for Arkanoid, you'll notice some of them actually have like the Space Invaders or like different kinds of bosses drawn using those color bricks up there to make it look like pixels and whatnot. So you have full control over what you're drawing. You can scale these bricks to be any kind of scale. So as I go through and give you the early structure of this project, realize that you absolutely have total creative control over this, and you could take it to your heart's content, take it to any level. But for demonstration purposes, I'm going to punch in some values that I've already pre-calculated that I know work well enough for what I'm doing here. So this object is actually going to be my paddle, so I'm going to rename it to paddle. Okay, its position, Y is not going to change, or sorry, X is not going to change, but I know I want to reposition it to negative 4.025. Now, these numbers are going to sound wacky, but all I did was drug it down, resized it to try to match up with this paddle here in the image. That's all I'm doing. So if you don't get these numbers exact, don't sweat it. Scale-wise, I need it to, in the X, be 1.2. And I also need to shrink down the Y a little bit to 0.25. Let's see here, 0.25. Okay, so that basically tries to map it on top of that brick, or the paddle rather. So now I'm going to use physics to control this object as it bounces around my scene. This is going to allow me to interact with a number of other objects without having to know certain other bits of math, like where my play bounds are and that kind of stuff. I'm going to rely on Unity's physics engine to control this stuff. To do that, I need to tell this object that it's capable of being controlled by the physics engine. To do that, with the paddle selected, I'm going to go to Add Component, clear out my previous script information. I'm going to go to Physics. I'm going to go to Rigid Body. Okay? So just the act of having that means if I hit play, watch that blink just drop to the bottom of my scene. That's because gravity is turned on, it's got a mass, etc. Now it's under the control of the physics engine. So that's cool. I'm going to actually modify this in code as opposed to here in the editor, and I'll show you the different settings once we get to that stage. So you can decide, do I want to customize this thing visually or do I want to customize it in code? The only issue with the code side of it is when I start combining things, like down here under constraints, right? When I start combining certain bits of information, it also introduces some new symbology in terms of code that you've not yet seen, but it's definitely useful, especially when you start trying to combine like layer information if you get into that part of like physics. So I'll show it to you. I'll probably have it maybe commented out. I don't know. Haven't made up my mind yet. It's very easy to do it here in the inspector. You're just clicking buttons as opposed to understanding what's going on behind the scenes in the code. But it's useful to know both exist. That's one of the cool things about Unity. Its power gives you both sides. You can deal with either. Okay, so now that we have the rigid body for the physics subsystem, I want to give this paddle a little bit of color. So down here in my materials, I'm just going to duplicate my wall material. So duplicate that, rename, and just call it paddle. And the color that I want to pick here, right? If I take my, let's see here. If I pick my paddle and I zoom in, all right, over here in my scene view, I can move this just slightly to the side. I like this gray strip right across the center of the paddle that's underneath it. So picking paddle, picking the color well, picking the color picker, eyedropper tool, I'm going to go over here and go right about there. Click. Okay, and now I can apply this paddle material to the paddle game object that I created a second ago. Now notice I could drop it in over here, right, over here in the inspector, but I can also just drop it onto the game object in my hierarchy. So when I let go, my paddle changes color. And now I can reset the transform X back to 0. That was just to get it out of the way so I could see what's going on. Okay, so at this point, I need a script that I'll start to customize here in a few minutes. So I'm going to call this paddle. Okay, I'm going to reorganize this a little bit. Move the paddle back up into the scripts directory. Okay, so that concludes all the necessary bits and pieces for the paddle. Now, I need to create a ball to interact with this kind of stuff, like bounce around my scene and hit things and whatnot. So I'm going to right-click, create 3D object. In this case, instead of creating a cube, I want to create a sphere, right? Because it's a ball. So, sphere. I want to rename this to ball. Now I can, let's see here. Yeah, I'll reset that. So now it's up there at origin. Now, the ball itself, it's a sphere, right? When we're doing scaling, if it's something that can be uniformly scaled in all 3 axes, it's a performance benefit to do that. If you start skewing it, sometimes it takes a little bit more CPU cycles to actually compute those kinds of numbers. So in this case, because the ball is uniform, I'm just going to drop it to 0.2 in the X, 0.2 in the Y, and 0.2 in the Z. Makes it pretty small, matches this ball down here at the bottom. Now, just like we did a second ago with the rigid body, I also want to control this thing with physics, so rigid body. Okay. I also want to create a material to make it look kind of like this little blue, light blue ball down here at the bottom on the paddle. So I want to grab the paddle material, duplicate it. This one I want to rename to ball. And now I want to target this ball sprite down here. So picking the image well, or the color well again, using the eyedropper. I want to pick this light blue, this cyan almost color in the center. Okay, and now I can apply the ball color material to the ball, and notice it changed color up here. Now you can definitely fiddle around with these other settings, make it look different, make it emissive, that kind of stuff, make it glow, etc. So now the ball needs a script. So add component, ball. It's going to be a new script. Cool. Okay, once it finishes compiling, we'll put that back in the scripts folder with everything else. Okay, and I'll give myself a target to actually throw the ball into. So right-clicking one more time in the hierarchy, go down to 3D object, and this one will also be a cube. Okay, its location is actually going to, I want to target this first green right here in the middle, just above the ball. Its current position is negative 0.021 in the x. Y, it's actually 1.111, and Z is 0. So that positions us proper. I want to rename this cube to be brick. And same thing, ball, paddle, wall. I want to create a material. In this case, I want it to be this green. Now I could duplicate the block and duplicate the material and give it like this magenta and blue and so on. But in this case, I'm just going to target this green layer. So with the ball material selected, duplicate that, rename it to green brick, and using the color well color picker, I want to target the lime green in the center of one of these blocks. Okay, and move this green brick, or apply it rather, to the brick. Cool, so now it matches. Now I can reselect my brick, and I need to scale it so that it looks like one of these other bricks. Now the scale on the brick in the X is 0.58, and the scale in the Y is 0.29. Now it's kind of difficult to see, which is kind of the point, because it's mapped in there, but I've also kind of made it a little bit larger, and you can verify this, double check it by going up to the Arkanoid layout image and turn it off. So now we can start to see how our scene is going to start forming. Right? As I pull back, I'm using the mouse wheel, but I also could use this scale slider right here to move around, and then I get these bars along the side that I can move around. I can also center mouse click and move around. So if you ever notice your scene is looking a little odd, but you've not really scaled anything, double check that your scale is set to, it should say like 1x. It's underneath this create button, right? It's a little difficult to see, but in any case. Okay, so now we've applied all of our calculations. We've applied the material to the brick, and now we need a script, because when we interact with the brick, it can deal with like self-destruction. It can do global counting for the total number of bricks in our scene. As we continue with the game, we'll actually use the brick to the bricks that are in our scene to determine whether or not we've actually destroyed all the bricks. If we have, we destroyed the last brick just a second ago, it will be aware in a way that then says, cool, now you can go on to the next level, be that level 2, 3, whatever, or the ending scene saying that you've won. So to make the brick itself self-aware, we need to create a brick script. Okay, and reorganize that just a little bit. Okay, so save the scene, and just so you can see, if I start playing now, the brick should stay still because I've not applied any kind of physics-related objects to it. The ball should fall under gravity, and the paddle should also fall. Okay, and you notice that little stutter right at the beginning when physics is the engine is kind of powering up. To kind of get past that, you can press and you can click pause, then click play to start the game. And now that everything's up and running, now you can unpause and everything functions without that jitter. So just something to keep in mind as you're play testing this kind of stuff. Sometimes you need to give Unity just a little bit of time to kind of sort itself out physics-wise. In normal scenes and normal games, this would be part of like your fade in, right? We tend to hide stuff like physics engine initialization because it can be a little screwy while its solvers are working out the equations, right? So we can kind of give that pause screen, but behind the scenes the engine is figuring itself out. So now everything in this scene is basically correct for what we want to try to do. Now I need to actually jump into those scripts. So I want to modify 3 of these scripts. I don't care about the game manager, so I clicked on ball, press and held shift, selected all the way down to paddle, and then I used control and clicked on game manager to deselect it. Okay, enter, and we'll reload the solution. And make sure everything actually comes back because that would help. Okay, so notice again it says miscellaneous files versus the project. So I'm going to go over here to my Solution Explorer, right click, unload the project, right click, reload the project. Give that just a second. And I can either jump back to Unity and try to open those files again, or I can do the exact same thing over here. Or not. Okay, so let's do this manually. Double click each one. There we go. Okay, so to actually get this thing functional, to see it under our own control, I'm going to start out by working on the paddle. So I know that I want to deal with some kind of input, right, to control this thing. So for this particular design, I want to use the A and D key for left and right, and I also want to back that up with the left and right arrows on the keyboard, just as 2 separate kind of inputs. Okay, so to do that, I know that I'm going to be monitoring for those key presses. The thing is, I'm dealing with physics. And it's good practice not to try to fiddle with physics inside update. If you refer back to that execution order page and just any general reading on the subject, specifically within Unity, the physics engine can actually tick faster or slower than the frequency of your update calls. So the idea is you want to kind of make requests and then respond to those requests. So what I'm going to do is I'm going to create myself a couple of variables, a couple of booleans, store that I asked to go left or right, and then apply that if I have indeed detected that I want to make some kind of movement. So I know that I want to control the velocity of the paddle, right? I want to slide it left and right based on whichever key I've pressed. So number 1, I know I'm going to be dealing with the rigid body. So starting up at the top, I'm going to flesh out the variables that I need. I know I need a rigid body. I'm just going to call it RB. RB. I said I want a couple of booleans to represent whether or not I've requested going left or right. So B left rec requested, and then B right rec requested. They're going to default to false, so I don't need to worry about shifting that back and forth. Now, when I modify the velocity, I'm going to go through, and the way vectors tend to work is you have a direction and some kind of magnitude. You can either add or multiply to scale that magnitude from like 1, right, on the unit circle or unit sphere or whatever, to give you a direction and how much power it's got. So when we start dealing with the ball, we're going to be actively fiddling around with both the direction and magnitude of the ball as it bounces around the scene. For the paddle, I'm going to do something very similar, but in this case, I just want to give it a little bit of an adjust, and I could tweak this. I could expose it to the inspector, make the ball faster. I could add power-ups to modify this number. I could use a multiply instead of a plus to like really ramp it up. The sky's the limit on this kind of stuff. So the variable that I want to work with is called speed. I want to name it speed. And this is the left-right speed of the paddle. And I'm omitting F here, but it's kind of automatic. It understands that 15 is actually a float. And now what I want to do is, when you're dealing with velocity on an object, if there's no inputs whatsoever, I don't want it to kind of creep across the bottom of my screen. Now you might, in which case you would modify your code to do that kind of behavior. But in this case, if I'm not pressing a button, I want to be giving it a 0 velocity modifier. If I'm pressing left, I want to modify it to the left by that speed. If I'm pressing right, modify it to the right by that speed. So I need to have some kind of variable that I can reset every single update, every single, in this case, it's actually fixed update. It's another, just like we were talking about start and update, and I introduced you to awake, which is actually called before start. Fixed update is the physics engine version of update. It runs at a fixed frequency based on whatever the physics settings are. Update, on the other hand, is actually variable. If you take a look at that graphic, the execution order, you'll notice that there are all these other systems in play before you get to update. Update has the ability to be called earlier or later and take longer or shorter from frame to frame. This is where, and if you haven't seen it already, you'll definitely see it going forward. This is where we start dealing with variable time slices. This is where time.delta time comes into play. When you're dealing with the physics engine, physics is one of those things where the math needs to be accurate 100% of the time. If it's not, stuff goes awry. It has to be, what's the phrase, deterministic. Update, on the other hand, can be kind of variable as long as we compensate for time manipulation. Like if you're running this on a faster machine or a slower machine, as long as you compensate for the fact that update took 2 times longer on this machine than it did on that other machine, then you're perfectly okay. So it's also totally possible that if you're dealing with like a really heavy physics-based engine or a physics-based game, you might need your physics engine to run 2 times per frame, 4 times per frame, so on, just so that it can do all the physics resolves necessary to make sure everything is as accurate as possible. Update, on the other hand, just the render that we see, right, the frame, the screen refresh, only needs to happen 30 frames a second, 60 frames, 120, whatever pick your poison. So in this case, I'm going to create a vector3 to store that direction modifier. Okay? So those are the 4 variables, or actually 5 variables, that we need to actually control this paddle. So I'm going to go through, and I need to first gain access to the rigid body on this particular game object. So the rigid body is equal to get component, which is going to search down through my current game object for this specific component called rigid body. Okay. And now this is the part that I said I can customize this over in the inspector, or I can customize this here in code. Now, the paddle, I need this thing to be like a Mack truck. When the ball hits it, I don't want it to move. Otherwise, it's very possible that it can do like a deflecting kind of glancing blow and make the paddle actually slide. The unfortunate side effect here, and if you go back and look at like last month's lectures where we're using physics, just physics, allowing it to bounce around the screen, I went in that lecture and created a number of physics materials and applied those to different objects, the walls, the ball, the paddle, that kind of stuff, so that they had bounciness factors, they had like the walls and the paddle were treated like granite. They had no bounciness whatsoever. So in this particular version of the code, I'm actually going to allow physics to do its thing. I'm actually going to use the often requested vector3.reflect to control what kind of reflections we have. I'm going to use the collision information to say what we collided with, what our new direction should be. But that also has some inherent issues. If you look at last month's lecture, you'll notice there are other issues that you have to compensate for if you want this to be a more polished title. Otherwise, you could potentially run into scenarios where your ball gets locked in, like, the velocity vector, the x gets locked so it doesn't go vertical. It could lock in the vertical so it doesn't go horizontal. And it basically means you're forced to stop playing the game. You have to turn off the game, restart it. The code that I'm going to write as we continue through this actually has a couple of fudge factors. I nudge the ball if I detect any of those scenarios. So yeah, it's smoke and mirrors, but that's game development in general. There are a number of tricks and things that we do behind the scenes to kind of make it appear to the end user that everything's fine. Meanwhile, we've got hacks in different places sometimes, Sometimes you're forced to, because maybe the physics engine does what it's supposed to do, but in this unique case, I need it to adjust accordingly. So in this case, I'm going to write the code here to modify the settings on that rigid body component that's on my object, but then I'll show you where you can also update that on the object itself. So I need to change the rigid body's mass to be that of basically a truck or car, 100 or 1 kilogram, 1,000 grams, whatever, or 1,000 kilograms, whatever. I also want to turn off gravity. I don't want my paddle to fall as soon as I start playing. So rigid body dot use gravity equals false. And now, because this paddle is locked into this particular X, it's going to be, number one, it's 2D, so it's going to be locked on that XZ or XY plane, but I also don't want it to go vertical, right? If the ball slams into it, I don't want it to kind of slide down or potentially slide up or whatever. So I need to lock its Y so it doesn't actually change. I also don't want the thing to possibly spin around my scene. So I need to tell the rigid body's constraints to basically freeze. Now you'll notice my tooltip window or my IntelliSense is actually updating with different bits and pieces. So off of the rigid body, I think this is an enum. Yes. This is a list of settings elsewhere in the engine that I can use. So I can say freeze position, and I said I want to lock it in the Y. And just like we did with string concatenation or with math, where we kind of stitch all this stuff together, we can kind of plus these things together. This is a special case, and this is what I was saying, that it's probably easier to see this actually in the inspector than it is to understand here. But going forward, you'll see this kind of code, so it's useful to know. Remember, we did the 2 ampersands for an and inside an if statement, but we also had the 2 pipes, the logical or. Well, there's a slight difference when we're doing math as it relates to these things. I want to use multiple settings, so I use one single pipe to stitch this stuff together. Now, it's not detrimental if you don't know this right now or understand it or whatever. It's just early exposure. You'll see this stuff going forward. Okay, and what it's expecting is, just like with the if statements where we're doing our checks, I need some other value right after that. In this case, I'm not doing a check. This is like a plus, right? So rigid body constraints dot, now I want to freeze rotation in the Z. Freeze rotation in the Z. And I also want to prevent the thing from rotating at all. Sorry, position. Freeze position in the Z. So one more rigid body constraint, freeze rotation. Now this one, I want to freeze all forms of rotation, X, Y, and Z. I don't care about any other ones. Okay, so these 6 lines of code This is how you would customize this inside code. Now, if I jump back to Unity real quick, and I select, we're talking about the paddle at the moment. If I scroll down to my rigid body, right, there's mass, right? So I'm modifying mass. I'm turning off the toggle for use gravity. And then down here under constraints, I'm using those ORs to turn off these values right here. It's the exact same setup, except I'm using code to do it. Okay? So it's useful to know that you have two different options with this kind of stuff. The code will override the settings that you have here. So when I start playing, these different things here will suddenly become toggled. They will change live. Okay? So now that I've got my physics locked to basically where I want it to be, let's see here. I want to actually go down and start handling the requests for movement. So inside update, and while I'm thinking about it, before I continue on to the next little segment, I want to jump back to Unity and save, and then jump back to Visual Studio and save. Okay, just getting that habit. It's a good thing. Program crash, you'll have a bad time. So inside update, if I do if input.getKey, now in this case using getKey because I want to pull the key press every single frame. Remember, getKey down was one single time until you release the key. So I'm looking specifically for key code A, or I'm looking for getKey key code left arrow. Okay? And at this point, I want to say that I have requested be left requested is true. Okay? Now I can do the same thing, but for the right movement. So being slightly efficient, I'm just going to copy all this stuff that I wrote and paste it, and be very sure to double check that A gets changed to D, left arrow gets changed to right arrow, and left request gets changed to right request. If you don't update those three things, stuff's going to possibly act weird depending on certain circumstances. One key won't function the way you expect it to, so on and so forth. Okay? Now I want to actually take those two requests, left or right, and push some kind of modification into the velocity of the paddle itself. Now to do that, I'm dealing with physics directly. So I need to use fixed update. And again, just punching that in will give me stuff like private attached at the beginning. I don't need that, so just delete it. So inside fixed update, that variable that I created up here at the top, the direction modifier, the speed, and the left and right are all going to get used in addition to the rigid body's velocity property. So I want to set, if I don't press any keys, if I'm just sitting there, I want to make sure that no velocity is being applied. So I don't want any residual velocity from the last key press to exist. Again, I'm only modifying the x, but because I'm going to be modifying a velocity, which is a vector 3, I need to stick with the same type. So that's why I use the direction modifier as a vec3 up there at the top. But I only want to modify the x component of it, or the x field of it. So here I'm going to reset it to 0 every single update. This will ensure that I don't accidentally push something I shouldn't into the velocity vector. So now, if I have detected a request for left, I need to, number one, turn off that request because I'm handling it now. So be left request now equals false. And I need to modify the x value. Instead of being 0, I want to actually give it some kind of number. So I'm going to, if I'm going to the left, I want to minus equals f speed And actually, I could just assign, well, I could also just say that this is equal to negative f speed, but I'm subtracting from 0, so it doesn't really matter. Either way will work. The plus equals and the minus equals, those are for modifying values that currently have something in them. So if that direction modifier wasn't reset to 0 on every frame, I could accumulate a value going forward, and I could make my acceleration, I could make the paddle look like it's accelerating. So additionally, if I've detected a write request, I need to handle the write request and say we're no longer dealing with it. The direction modifier .x in this case will be plus equals f speed. Okay, and now that I have properly filled out those two directions, I can actually apply this to the rigid body's velocity, the direction modifier, and just set it directly. Okay? So now, if I jump back over to Unity, let that compile, shouldn't have any issues. Now, as soon as I start playing, you'll notice mass will change, gravity will change, and these constraints will change down here. So, and boom. 1000 turned off, and then we lock the rotation in position. We only allow for physics to be moved in the X position. So now, with the game window in focus, if I use A and D, my paddle goes left and right. If I use left arrow, right arrow, it does the same thing. Now I'm allowing the physics engine to control the bounds, right? It's slamming into the walls and it won't actually exit the play space. So this is the basics for actually dealing with the rest of the game. Now you'll also notice that if I press and hold both A and D, or left arrow, right arrow, the paddle doesn't go anywhere. That's because instead of, if I stop playing and look at my code, you'll notice that these two statements, this if and this if, they're not linked together using an else. Actually, space those two apart and space those two apart. So on any given frame, I could be pressing both the A and the D, which means I've requested both left and right. So that becomes a null value, a zero-sum game. I move left by one step, then I move right by one step. Well, I'm back to 0. So if I wanted to enforce that if I press both those keys at the same time, one of the two will override the previous, I could throw in an else, and it would chain those two commands together. Whichever one was detected first would happen, and then the next one would be ignored. Okay? I could do the same thing down here with my left-right request. I could put an else right between those two ifs and dramatically modify how the game played. Okay? So now we need to actually take that ball and fling it around the scene. So there's a fair amount of code inside the ball to actually get it functional. So this particular bit might actually carry on into next lecture. Almost certainly will. But we'll go right up to 7 and see what's happening. So at the very least, we've got something in our scene bouncing around. We see movement. We have control over at least one thing in there. And the rest of it, once we flesh out the rest of the ball, the brick itself, and then the game manager, that's the gameplay loop. That's the core functionality of this entire thing. So taking a look at the ball, we've got very similar aspects to what we just dealt with the paddle. I need the rigid body, RB. I'm going to take the ball, and I'm going to, as soon as the game starts up, I'm going to take information about where the paddle's at and where the ball's at. I'm also going to take information about its size, right? Because I've scaled both the paddle and the ball. So its physics, in terms of its what is it? It's colliders. The information that you can request from the system, it's going to be slightly different depending on what specific problem you're trying to solve. In this case, I actually get correct information coming off of the renderer of all things. So I can ask the renderer of these objects what their current sizes are, and it will give me the proper scaling, to take into consideration. So what I'm going to end up doing is I'm going to take the ball and I'm going to physically position it right on top of the paddle, but then I'm going to offset it by half of the paddle's vertical distance and half of the ball, the radius, so that they basically sit right on top of each other. Now that's going to allow me to, before I start playing, right, I can hit play, but before I actually launch the ball, that's going to allow me to move the paddle left and right, but keep the ball fixed to my paddle. Now when I do press the fire button, I launch the ball into my scene, I no longer want that attachment logic to function. I also, as I'm controlling physics here, both in fixed update and like when I actually do the launch code, I want the system to initially kind of ignore certain things. I want to know whether or not I'm actually playing or not. And when I click fire, then it comes in and says, start functioning differently, right? One system starts behaving differently than what it was before. So to do that, I need to basically know when I've started actually playing the game and then change the behavior. So to do that, I want to track a variable that will let me know if I'm actively playing right now. Now, next lecture, once we go into refactoring some of this stuff, this is isolated. This bit of functionality I'm about to write is isolated to the ball, and we'll have a similar thing isolated to the paddle. When we get into the game manager, I'm going to move where these calls and how they all interact so it's centralized in one single spot inside the game manager. It's going to allow that one system to control gameplay across the board. So for now, I need a Boolean to tell me whether or not I've started or not. I'm going to call this B is playing. The ball itself needs some kind of a direction to be flung around the screen. This is exactly the same as with the paddle being moved left and right. This is all very similar code. It's just used slightly different to control different aspects of the gameplay. So I need a vector3, and this one I'm just going to go ahead and call vdir, right? It's not necessarily a direction modifier. It's the actual direction. They're basically the same thing. I also need to give it some kind of power. This is very similar to speed. Float f power. And I want to just, let's see here. I can default this to 10, but I'm going to override it in code, so this actually doesn't matter. Okay. So when I start this scene, I need to gain access to that rigid body and the rigid body that's on the game object over there in the inspector. So get component, rigid body, and now exactly like I did with the with the paddle, I can customize these settings in the inspector, or I can customize them here in code. So for giggles, I'm going to do it here in code. I don't want to use gravity, so I'm going to turn that off. I don't care about the mass of the ball. The ball can do whatever it wants. I just needed the paddle to stay fixed. Anything slamming into it wouldn't have any impact. What I do, however, want to do is modify how the ball's physics is calculated every single frame. The default version, if we jump back over to Unity real quick, take a look at the ball. Under rigid body, you'll notice I have various settings to control how the physics engine works with this particular object. Now, collision detection is kind of the key thing. If I get the acceleration on this ball high enough, I can make it penetrate any of the walls. I just fling it right out of my scene. So I can basically tell the physics engine to pay more attention to this object than it normally would. That way I can get higher and higher velocities up to a point. I mean, there is a threshold. But larger than the initial threshold. So basically, I want to change this from discrete to using continuous dynamics, or continuous dynamic. But I want to do that over in code, so you can see that happen one more time. So off of the rigid body, again, this is called collision detection. So we should have a collision detection mode, right? And I want to assign it to collision detection mode dot continuous dynamic. And you notice these settings are exactly the same ones you saw in that drop down a second ago. And to sort out that new line side of things, there we go. Pull it back onto one screen. Now I also want to modify the constraints. Now the ball, one second. The ball, I also don't want it to tumble in any way. I don't want it to rotate as it flies around my screen, but I also don't want it to fly into or out of my scene. I want it to lock on the z-axis. I only want it to bounce around in the x, y, whereas with the paddle, I only wanted it to function across the x. So I want to tell the rigid body's constraints to be set to rigid body constraints dot freeze position, but only in the z. And I also want to add rigid body constraints dot freeze rotation, all of rotation. Okay, and once again, these are identical to toggling these like so. Okay, so now I want to go ahead and just say, fire the ball into my scene, right? At some point, regardless of what it collides with, regardless of those edge cases I talked about, we still need to be able to just fire the ball into the scene. So I'm going to, let's see here, do I even need update? Because I'm going to allow physics to deal with this thing. At some point in the future, I'm going to retool update. But for the moment, I can leave it. I don't need it. Let's see here. Actually, I want to undo that. Didn't mean to pull that down. After update, I want to create a method called launch. And the idea is to call this from the paddle when I press a button, right? I hit spacebar and it fires my ball into the scene. So to call it from elsewhere, I need to make it public. Okay? And so the way I'm going to construct all the physics for this particular object is when it bounces off of something, I want to do some kind of velocity modification. I want to take whatever my new direction vector is, right? When we slam into something, we'll do the vector 3 reflect to get a new direction, but we also want to restore the magnitude, the power. The thing about the way this physics engine works is, as your ball is flying around the scene at some particular magnitude, as soon as it slams into something, the physics engine says, shave off a certain amount of that magnitude, of that velocity. And so when you respond, when you query it, when you ask the rigid body for its velocity inside like collision, right, on collision inner, you'll actually get a modified vector. That won't be what it impacted with. That'll be after the fact. So we'll need to go through and, again, using that graphic, the execution order, if you notice at the top of the physics block, fixed update happens before the collision and the trigger and a handful of other things responds. So we know, based on that graphic, that we have valid physics information just before the act of slamming into something occurred. So I can take a step back in time, basically, in terms of the engine, and I can say, what was my velocity? What was the magnitude specifically? I now know I have some new direction based on reflect, but now I can restore the magnitude. Well, that calculation is going to be used in a few different spots based on some edge case scenarios, based on the generic launch code, based on the collision code. So I want to write a little bit of functionality off in a method. And again, methods are simply for wrapping up wrapping up functionality elsewhere, reused functionality. So I'm going to call this apply velocity. It doesn't need to be called outside of this script, so I don't need public on here. Now my intent is to set the rigid body's velocity to something. Now I'm going to, as I slam into things, I'm going to be calculating or recalculating that v_dir value that I had up at the very top. So v_dir. Now the thing is, no matter what the impact was, no matter how hard I flung it into my scene initially, whatever that power value is, I only want the unit vector version of this thing, the normalized. So scale it, no matter how big it is, no matter how small it is, scale it to 1.0. That way I can multiply the power and get some kind of a uniform bit of math here. So I need dir's normalized, and I want to multiply that by the power F power that I calculated earlier. And now a neat little thing that I can use to just show myself where this thing, what direction I actually chose is off of the debug class. You've seen log a zillion and one times at this point, but I can also go through and say draw ray. I want to start this thing with, right here, start, a position, and a direction. So my current starting location is this transform dot position, EOSIT island. The direction, which we just calculated with the RB dot velocity, which will include that magnitude value as well, the power value. And I'm just going to, let's colorize this with blue. And how long do I want to stick it around? What's the duration? Let's just go with 60 seconds. We can definitely shave that value down as time progresses on. Okay? So that's going to allow me to impact how this thing gets flung around my scene. Now, when I click launch, when I click the space bar, when I press the space bar and I fire this ball into the scene, now I've basically officially started playing. So I can say here inside launch, B is playing now equals true. Okay? And I can apply the velocity that I would have just calculated. Now the thing is, I actually need to calculate a velocity, a direction to give this thing. So I'm going to use a little bit of math to basically take the sphere, which is currently pointing down the z, right? It's 0 is flat, pointing to the right, and I want to move that in the rotation around the z counterclockwise, which is going to give me like positive numbers. If you look at this over in Unity, if I get the ball, focus in on it, and using the Z here, if I click and drag, see how the ball is rotating counterclockwise over there in my scene view? That's what I want to achieve. Now, when I fire the ball off of my paddle, I want to dictate what its launch cone could be. So I've come up with the values of between 45 and 135. That gives me a good 90-degree range at which it could launch from. So I can undo that, jump back to Unity, sorry, Visual Studio. And so I want to say that my minimum degrees is 45, and my maximum degrees is 135. Okay? Now, I can come through and using the math library, right? We saw some stuff earlier with mathf.pow. We saw some epsilon stuff and whatnot. So in this case, I can calculate the value for the new direction based on the math. Like I could go in and say I want a 3D a vector 3, and I could say my x component is this, my y component. But sometimes it's more conducive to think in terms of angles. And we tend to think as humans in terms of degrees. The computer thinks in terms of radians. So we can real quick use the trigonometry, cosine, sine, that kind of math to basically take what this value is in radians and then get a vector from that. So the math to do that is kind of twofold. The first thing I need to do is convert my degrees into radians. So float f rads equals. Now you'll notice I don't have a degrees value just yet. That's because I gave it a range, 45 to 135. Well, I want to randomly pick some number in between there. So I can now say float f degs, f degrees, is equal to the random class dot random range. And this is the thing I tried to show you a few lectures ago, where I get two versions. If I use the integer version, that's not showing it to me, but it'll give you a different maximum. It's actually maximum -1. But the float version is the entire thing. It's inclusive on both sides. So I want to take the minimum degrees and the maximum degrees, and I want to just pick a random number between there. That's going to give me that cone. So the degrees now needs to be converted into radians. Well, mathf, that library, contains a constant value that you would multiply to then turn it into radians. So deg2 rads, or deg2 rad. Now, using that radians value, pushing that into both sine and cosine, I can get whatever its x and y component is for that vector. So I know that I want to store the return inside that direction, right? So I need a new vector 3, because this is going to overwrite whatever that value was, and I can't just assign this directly. I need to call out to mathf dot sine for the x, and I need to pass in the radians. And I need mathf dot sine also of the radians to get the y component. Now I said earlier that this is a 3-component version, but I also don't need to apply the third thing. Notice right here, 2 out of 3, this one only requires 2 entries. So that's what I'm going to go with. I can omit the fact that the last parameter is 0. Okay? So that will calculate me a new direction vector. And just like I did a second ago with calculating the ray, that based on where I impact, like I said, this is going to be used in a number of spots. So I'm going to see this as it bounces around my scene in the next lecture. But for this launch, maybe I want to see it in, I don't know, a slightly different color. So I can take this same bit of code, copy it, paste it up here, change my color to yellow. Okay? And just as a fun little demonstration of seeing this actually happen, not just once every frame, like I could just for debugging purposes, I could wrap this in a for loop, for int I equals 0, I is less than, let's go with 50 times just for giggles, I plus plus. Now I'm going to run this random calculation and draw 50 times. And whatever the last one is, that'll be my final value, and then apply velocity will actually draw that blue value. But also notice I'm calculating dir. I've not calculated rigid body velocity yet. Rigid body velocity happens down here in apply velocity. That's where this recalculation occurs. So I need to actually replace rb.velocity with vdir. Okay? Saving that. This will function, it just won't do anything because I've not actually called it. So I need to jump back over to my paddle and make use of this code. So wrapping up this lecture, over here inside the paddles update, if I drop down just below my two left and right scenarios, I also mentioned a second ago that with the ball I have whether or not I'm playing or not, so I can do one form of logic versus another. I need to do the same thing here inside the paddle. So real quick, jumping back up to the top, I need to do a couple of things. I need to get access to that ball so that I can actually call that method that I just created. And I also need to say whether or not I'm playing. Okay. Inside start, I need to look in my scene for the ball. So B equals find object of type. Look for the ball. Okay. And I'm not worried about the offsets right now. I'll take care of that in the next lecture. But now that we've actually got the ball, we can call out and say, fire this thing into the scene. So if I'm not B is playing, and this acts as a security feature so that I can't mash spacebar numerous times and inject, the same kind of call, apply a different velocity each time. I could turn this off and just say fire it a zillion times. Yeah.
Why do you have in the script that you freeze on the positions, but when Unity you can just click that button?
I'm showing you both ways. You'll sometimes see, every so often you'll see code that for one reason or another, because of maybe timing or because the object doesn't exist yet, maybe it's created live, like actually constructed in code or something like that, that you can't make these kinds of settings in the inspector. It just simply doesn't exist yet. So this is the exact same thing as if you set it over inside the inspector. 100% identical. Every one of these names, these would be the checkboxes, the value behind it, behind the scenes that the engine's looking at. Yeah, it's one way. It's two ways to do one specific thing. There's no rhyme or reason. I could very easily jump over to the inspector and do the same thing. The idea is this particular class is more about learning to see code, not necessarily learning to see Unity's interface. So in your other classes, you'll definitely be moving stuff around, doing stuff in the UI, but you also need to be aware that you can easily do this stuff in code. Here's how it looks. So if you ever run across example code, it's like this is going to be familiar enough that you could, oh, I remember seeing this kind of thing where I'm squishing different kinds of variables together in different ways, not just in the inspector. Cool. Okay, so we've got the ball. If we're not playing, I can actually start responding to the spacebar being pressed. So input.getKey down, because I only want to do the one single key, key code.space. Okay, and now I can do two things. One, I can stop playing. That way I don't have the potential of mashing spacebar multiple times. It's just the design I happen to go with. You could absolutely fiddle with this and make it happen numerous times. It would be kind of odd to your gameplay, but totally possible. And now, coming off of the B object that I created a second ago, I need to call launch. Okay, so at this point, I'm going to save that script. Do one real quick pass to make sure that everything so far, yep, looks good. Okay, jumping back to Unity, everything should compile without issue. And now it's not fully hooked up, so you're going to see stuff like the ball won't reposition itself, right? I've not done that kind of stuff. I've not engaged any of the collision response stuff. This is strictly for firing the ball into the scene. So as soon as I start playing, if I press the space bar, you saw the ball started flying up into the scene. But if you notice over here inside my scene view, this arc are those 50 yellow rays that it could randomly have picked one of those, and this blue line is the direction that it finally chose. So I could stop playing, play again, and notice I paused real quick so we can see the ball fired up, would have interacted with this brick, and hit it and slid over. This is one of those scenarios where the impact alone nullified the vertical component of that velocity vector. So it's no longer going vertical in any way. It's just going to continue to creep along my screen to the right-hand side. We'll sort that out when we start dealing with the collision, when we start looking at what it was, the direction and magnitude and that kind of stuff, what it was before we actually slammed into something. So at this point, you've got a paddle moving around the scene. We've got an object we can slam into, both the play area as well as that one brick up there. We've got a ball that we've successfully been able to randomly launch into the scene. Notice it picked the other direction, and this time, because it didn't hit that block, it flew all the way up here into the corner, slammed into the top wall, and is now just creeping along. So we'll resolve all of these collision and fine-tuning of the physics stuff in next lecture. Cool? So if you have any questions, comments, concerns, fire them off to me. Yeah?
Do you go into greater detail with the ratio when the ball fires? Because I took a class a couple months ago, and my game broke with that.
When you say the ratio, are you referring to...
Like the spread. When you hit space and it shows you that spread when the ball fires, do you go into greater detail in the later lectures with that, like to possibly debug if it gets stuck to the right? Because my game, I had it going 90 degrees every time it hit space. There was no... Well, I talked to you about this before, too.
I think so. Yeah, there's a few different ways that the code can be broken. From the inspector side of things, from the Unity inspector side of things, you could accidentally apply a rigid body to an object that you didn't intend to, which means physics steps in and tries to modify things. I've seen it before where applying a rigid body to the bounds, as soon as the ball hits the bounds, it starts to like snake along it and actually wrap and do this weird thing. And it's strictly because physics is like, oh yeah, you actually intend to do this other thing, when that's not what I intended at all. This is more math. The only reason I threw this in here was because the first version of this would go through and just say, create myself a vector 3 and just say my x component is anywhere between -10 and 10. Okay, my y component is 10. That's my maximum. So I create this like square, right? And I just say somewhere in this range, and then I pull that back down to the unit, so I get a direction off of that. This way gives it a little bit more, it's more dynamic, but then we can also see it happening. We apply, because as you, just generally speaking, as you continue developing different game ideas, prototypes, the rest of the program, you'll be fiddling around with different little bits and pieces of math here and there. In some of the other classes, you'll be doing stuff with like dot products to do half space tests and backstab tests and that kind of stuff. And so understanding that gameplay a lot of the time is governed by simple bits of math. In this case, if you just Wikipedia, look up, or Wolfram Math or whatever, take a look at just what cosine does to radians, how it represents numbers on a unit circle, right? Also how sine works, how it's shifted, how it's out of phase by 180 degrees or whatever. You can basically say, if I plug in 0, what's it going to be? And you'll actually get like 1 to -1. And those are the numbers that I'm basically plugging in here. So I go through and say, I want to take the visual side of things, right, over here inside Unity. I know that if I grab this ball, right, and just for example, if I switch this back over to local, if I start fiddling around with these numbers, notice that red arrow. That's whoops. Yeah, wrong screen. So manipulating this value, right, kind of visually gives me an indicator. So I want to take that value as if it were degrees, convert it into something the computer understands, which is radians, and then that's the math side of things that what is it, the trigonometry, the sine, cosine. That's where all that stuff actually plays. That's its arena.
So you're taking the radians off of the ball instead of the actual like math of the game. There's probably a dumb question you might not understand.
Well, I'm taking the ball, and I know just unity in general. I know that at no rotation whatsoever, that's the current thing. That's the current orientation of the ball. But if I switch over and I use the rotation gizmo, I can grab hold of this thing and say, well, what if I wanted to, arbitrarily launch along this axis? Or if I pull it back over a little bit, over to that axis. So I'm visually, thinking to myself as a visual thinker, I'm going to follow from origin of the ball up through, and I know that this ray versus this ray, and I want to cover that arc. So I'm just going to randomly pick between, and if I look at my numbers over here, if I set this, let me jump back to,
And that's your 45 to 135?
Yeah. So if I in global mode, it's kind of difficult to see what's actually going on here. But if I switch this to local and I change the coordinate system to map, I can use my visual gizmo. And in this case, this red vector, if I say 0, it's 100% to the right. If I go anti or counterclockwise to the left by just a few degrees, if I start counting it up, right, positive means the ball is going to start rotating counterclockwise. So now if I just go in here and say 45 degrees, I'm following that red vector, that's a good maximum over on my right side. I don't want it to go more clockwise, but I want it to go more counterclockwise. So I'm going to create a cone, a visual cone from this point over to somewhere about here, right? So those two locations, joink, let's see, 45. So these two, no, that didn't work. All right, well, valiant attempt.
I see what you're trying to do.
I was going to try to show them both here. Now the thing is, it gets much more complex, but there are ways to visualize this over here inside the scene side of the inspector. Like I can, the visuals that we have for the camera, for lights, those kinds of things. There are these things called handles that are built into the editor, and you can script this stuff out to give these. Like notice when I hover over, they change color. Well, I can also draw like arcs. I showed you drawing ray, but you can also draw lines, debugging, that kind of stuff. Handles actually allow you to interact with this stuff. Like these right here, these are all handles. These are manipulation gizmos. I can click on these things and do stuff to the object in question. So when I'm referring to the rotation, I know I'm going to be working in the rotation concept, but I'm not actually applying a rotation to the object. So I'm just kind of taking a leap, knowing that I can use the object's artificial rotation to verify that 45 and 135 are a good minimum and maximum. I can take that information, which is degrees, right? I'm thinking in terms of degrees. I want to move that into trigonometric space or whatever, so that sine and cosine actually return me some kind of specific vector information. That vector it would be, because I'm dealing with sine and cosine, it would be normalized to that unit circle. Let's see here. Let's see here. If you look at, right, just trigonometry, unit circle, that kind of stuff, you find that sine and cosine give you different points depending on what values you pump into it. And so converting in this case, like this guy, 0 degrees is to the right. So if I say 45, in this case, cosine is the x, sine is the y. If I pump in 45 into both of those values, I'll be given back the x and y components that make up this line going right up here into 3D space. If I then randomize that between 45, this ray going off in that direction, to 135 over here, I now have somewhere in this arc, and again, because it's dealing with sine, cosine, and we're dealing with like unit vector normalized stuff, it'll maintain that 1.0 length, or it'll maintain proper math. So I then say, give me some number between this point arcing over to this point. Randomly pick one of those things. Now I do that for loop of 50 just to demonstrate what it potentially picked. So every one of those things is just firing off a single unit length ray saying I could have gone any one of these things, and when it finishes, the very last one being the blue vector, that's what gets the power applied to it and then fed into the rest of the system. So that whole thing is nothing more than a demonstration, a visual demonstration of how to come up with this kind of things. It adds a little bit more variety to what you're seeing as far as how the ball could be launched in my scene. You will, just generally speaking, as you continue working with objects and math and like how to determine certain things, these basic trigonometric functions, mathematical functions, sine, cosine, dot, cross, that kind of stuff, you'll use this in vector math a fair amount. So it's acting as kind of a little bit of a review, but you can actually see it live going between three different number spaces: degrees, 2 radians, 2 velocity vectors. So let's see here. So I'm using several different bits of code all together. I've defined my range with these 2 values, minimum and maximum. I've said just give me a random value, doesn't matter which, just between that range. I take that number, convert it into radians so that I can use sine and cosine. I fill out the x component of this vector with what cosine returned to me from that graphic you saw just a second ago. Cosine is x, and then sine gives me y. That then becomes, on that unit circle, some direction between 45 and 135 that I can then apply going forward. Now, depending on what segment of code you're talking about from the last version, I think that one had like add and show. It used similar code to this, but it was a little bit more complex in its method naming and whatnot, and it did it in several different spots. It's different this time around. I don't do some of that other stuff. Like when I in that version, when I impacted something, I randomly calculated go somewhere, which could potentially say if I just slammed into a wall, my new direction I want to go is further into that wall. So it could potentially be a bug that I had yet to discover where it further slid, and then as it's possibly colliding, it's further penetrating into that wall. That's totally a possibility, and extreme playtesting would have surfaced that. In this case, I've changed up the code. We're going to use collision detection and reflect to basically say if I've just slammed into something, go the exact opposite way. And we'll see some of the fallout with that decision, as well as some of the compensation code that has to be used to get us out of certain edge case bugs. So it should be a little bit more simplified in terms of its logic by comparison to what you would have seen in the last version of this project. Cool. Awesome. Yep. Anybody else? No further questions from here in class? Okay. You are all free to go. I'm going to stop the recording and respond to the questions over here in chat.